Evaluate the limit as t approaches 2 of t squared minus 4 multiplied by cosine of 1 over t minus 2. First off, notice that if we plug in 2 into this expression, we'll get cosine of 1 over 0, which would be undefined, or you can't divide by 0. So what we have to do is use the squeeze theorem for this cosine part. So if we remember that cosine of any angle, any value in the cosine, has to be between -1 and 1. -1 is the minimum it could possibly be, and 1 is the maximum it could possibly be. And so if we use this inequality, we can manipulate it to get the limit, this limit, in the middle. And by the squeeze theorem, if we evaluate the limits on the outside and they're equal, then this one must be also equal to it. So you can see what I mean by as we go along. So if we multiply all three parts of the inequality by t squared minus 4, because again, we're trying to get this limit, so we multiply by t squared minus 4. Then we take the limit as t approaches 2 of all three parts, like this, and notice this is our limit that we want in the middle. And the limits on the outside we can actually evaluate just by plugging in 2 for t. So we get 2 squared minus 4, that's 0, and so the left part is 0. Similarly on the right, 2 squared minus 4 is 0, and so you can see we have 0 less than or equal to this limit that we want, less than or equal to 0. And so by the squeeze theorem, because this limit is greater than or equal to 0 and less than or equal to 0, that means it has to be equal to 0 in order to satisfy both inequalities. And so we can say that the limit is equal to 0.